Malik, and I'm going to do a word problem from the book Thomas Calculus, chapter number 3, additional exercises, question number 28. So I've written down the question over here and I'm going to read it out. So it says that an ice cube retains its cubical shape as it melts. Its length is S and the volume is V. We assume that the volume decreases at a rate proportional to its surface area. The cube lost 1/4 of the volume in the first hour. How long will it take to melt completely? So we have a cube with length S and volume V. So we know that V is equal to S cube, the first relation. So we also know that the rate of decrease of volume is proportional to the surface area. It is decrease and therefore the rate is negative. So we can write this as dV upon dt is equal to minus 6k s square, where k is greater than 0 and it's the constant of proportionality. So we know that at time equal to 0 the volume was V naught, say, and the side was therefore S naught. At time equal to 1 hour the volume became 3V naught by 4 after losing 1/4 of the volume, initial volume, and the side becomes 3/4 to the 1/3 S naught, since the side is proportional to the cube root of the volume, right? So it's equal to, not proportional, yeah. So we can write the volume in terms of side length S. So we get that d upon dt of S cube is equal to minus 6k s square. This implies that when we differentiate we get 3s square ds upon dt is equal to minus 6k s square, and when we divide by 3s square on both sides we get that ds upon dt is equal to minus 2k. So this is a linear rate of decrease, which means that the graph, when we graph s versus time, the length versus time, we get a linear graph, a line. So it starts from s naught at time equal to 0 and ends at sometime t at s equals to 0. So we want to take out the slope of this, which is ds upon dt. So we can write ds upon dt is equal to delta s upon delta t. Since it's linear, the rate of decrease is linear, and delta s is equal to the final minus the initial upon the delta t, which is 1. So we know the slope, right? And this is also equal to minus 2k. Now if we use the slope point form, which is y minus y1 is equal to upon x minus x1 equals to the slope m, we can write this for this line, and we get that s minus the length at 1 hour, which is 3 to the 1/3 3/4 to the 1/3 s naught upon t minus 1, which 1 hour, is equal to the slope, which we just took out. It comes out to be 3 to the power 1/3 3/4 to the 1/3 minus 1 times s naught, right? So when we multiply on both sides by t minus 1, we get that s minus s naught into this is equal to s naught times 3 to the power 3/4 to the power 1/3 minus 1 times t minus 1. When we simplify this, we get that s is equal to minus s naught t times 1 minus 3/4 to the 1/3 plus s naught. So this is the equation of this line. When we take s to be equal to 0 when the cube actually melts, we can take out t. So we subtract s naught on both sides and we get minus s naught equals minus s naught t times 1 minus 3/4 to the 1/3. We divide by s naught times 1 minus 3/4 to the 1/3 on both sides, and we get t is equal to 1 upon 1 minus 3/4 to the 1/3 hours, right? So this comes out to be approximately 11 hours, and that's our answer. Thank you for watching.